Good morning. Today I'm going to present our physics year topic laser in optical fiber communication. I'm going to taking the introduction part of this year presentation. Laser stand for light amplification by stimulated emissions of radiation. In this PPT, we are going to gather a knowledge or information about laser. Laser is a device that emits light through process of optical amplification based on stimulated emission of electromagnetic radiation. The first laser was built in 1960 by Theodore H. Meeman. The laser differs from other sources of light because it's emitted from the coherent sources. The spatial coherence allows laser to be focused on a tight spot, enabling applications such as laser cutting and lithography. Spatial coherence allows laser beam to stay narrow over great distances, enable applications such as laser pointer and lidar. Now, in this PPT, we are going to know about laser communication. Laser communication is a system in another mode of telecommunication which occurs through wireless connections in atmosphere. In this mode of communication, the information is transferred through free space. In laser mode the signals are transmitted from wireless transmitter to wireless receiver without any hindrance. Laser communication came into existence in late 1960s. Fiber optic communication. Fiber optic communication is a method of transmitting information from one place to another by sending pulses of infrared light through optical fiber. Fiber is prepared over electric cabling when high bandwidth, long distance, or immunity of electromagnetic interference is required. Optical fiber is used by telecommunication companies to transmit telephone signals for communication and cable television signals. Now, the working of the optical fiber communication is explained by my teammate Suryan Singh.
Thank you, Vansh. Now I am going to explain how do fiber optic communication works. Firstly, the analog information is transmitted to coder or converter, where it is converted to digital pulses with alternate binary codes of 0 and 1. Now it is transmitted to light source, where it is passed on through fiber optic cable which carries the information. Now the information is passed on to amplifier, where the information gets amplified, and lastly the digital pulses are converted into analog output by a decoder. Transmitter side. On the transmitter side, first, if the data is analog, it is sent to a coder or converter circuit which converts the analog signal into digital pulses of 0, 1, 0, 1 and passed through a light source transmitter circuit. And if the input is digital, then it is directly sent through the light source transmitter circuit which converts the signal in the form of light waves. Optical fiber cable. The light waves received from the transmitter circuit to the fiber optic cable is now transmitted from the source location to the destination and received at the receiver block. Receiver side. Now on the receiver side, the photocell is also known as light detector, which receives the light waves from the optical fiber cable, amplifies it using the amplifier and converts into proper signal. Functions of different components in optical fiber communication. First, signal converter. The duty of signal converter is to convert an analog signal into different ones, like digital pulses. Light source, depending on the applications like local area networks and long haul communication systems, the light source requirements vary. The requirements of light source include power, speed, spectral line width, noise, ruggedness, cost, temperature. The two components of light sources are light emitting diodes and laser diodes. Light emitting diodes. The light emitting diodes are used for short distances and low data rate applications due to their low bandwidth and power capabilities. Two such LED structures include surface and edge emitting systems, laser diodes for longer distances and higher data rate transmission. Laser diodes are preferred due to its high power and high speed and narrower spectral line width characteristics. Low loss optical fiber. The optical fiber is a cable which is also known as a cylinder dielectric waveguide made up of low loss material. Optical fiber also considers the parameter like the environment in which it is operating, the tensile strength, durability and rigidity. The fiber optic cable is made up of high quality extruded glass, silicon or plastic and it is flexible. The diameter of the fiber optic cable is in between 0.25 to 0.5 mm. A fiber optic cable consists of four parts: core, cladding, buffer, jacket. Core. The core of a fiber cable is a cylinder of plastic that runs all along the fiber cable's length and offers protection by cladding. Due to internal reflection, the light traveling within the core reflects from the core and the cladding bound. Cladding. Cladding is an outer optical material that protects the core. The main function of the cladding is that it reflects the light back into the core. When the light enters through the core into the cladding, it changes its angle and then reflects back to the core. Buffer. The main function of the buffer is to protect the fiber from damage in thousands of optical fibers arranged in hundreds of optical cables. Jacket. Fiber optic cable jackets are available in different colors that can easily make us recognize the exact color of the cable we are dealing with. The color yellow is clearly signifies a single mode cable and orange color indicates multi-mode. Now my EL mate Yash is going to explain further.
Thank you, Suryansh. I am Yash and I will be explaining further. So here is given a photodetector. The purpose of photodetectors is to convert the light signal back to an electrical signal. Two types of photodiode are mainly used for optical receivers in optical communication systems, that are PN photodiode and avalanche photodiode. Depending on the application's wavelength and the material composition of these devices vary. These materials include silicon, germanium and etc. So use of laser in optical fiber, that is why is laser used in optical fiber. In optical fibers it is necessary that fiber optic links can operate over longer distance. We need large distance communication between the continents and all. So with higher data rate, so lasers are used in. The light output is directional and this enables a much higher rate of efficiency in transfer of light into the fiber optics cable. Lasers have a narrow spectral bandwidth as a result of the fact they produce coherent light. This enables the laser to transmit data at a higher rate. So the next are given characteristics of fiber optic communication. So first is bandwidth. Single laser light dispersion means that a good amount of signal can be transmitted per second, which results in high bandwidth over long distances. This is why optical fibers are used in place of copper cables, as they have greater bandwidth than copper cables. So it is also of smaller diameter. The diameter of optical fiber is only about 300 micrometers, and optical fibers are lightweight compared to the copper cables. And since the laser light doesn't disperse, so it can be easily transmitted over long distances. And it also has low attenuation, that is loss of data. The fiber is made of glass and laser is traveling through it, so the attenuation is quite low. And it has also transmission security, that is over long distances that the data in it is secured, as it is in the form of light. There are two types of optical fibers, that are multimode optical fiber and single mode optical fiber. Multimode fiber allows a large number of modes for the light ray traveling through it. The core diameter is around 40 micrometer and that of cladding is 70 micrometer. The relative refractive index difference is also greater than the single mode fiber. And there is signal degradation due to multimode dispersion. It is not suitable for long distance communication due to large dispersion and attenuation of the signal. So the losses are more in multimode optical fiber. And the single mode optical fiber, in single mode optical fiber only one type of ray of light can propagate through the fiber. This type of fiber has a small core diameter, that is 5 micrometer, and high cladding diameter of 70 micrometer. And the difference between the refractive index of core and cladding is very small, and there is very less dispersion, that is the loss of signal due to dispersion, because in comparison to multimode optical fiber. And the light dispersion, the light is passed through it through laser diode. So my teammate Rishabh will explain further.
Thank you, Yash. I am Rishabh and I will be talking about the other two types of optical fiber, its application as well as fiber getting. So, The other type of, so the next type of optical fiber is step index optical fiber. So basically in step index optical fiber, the refractive index of the core as well as the cladding is constant, and the ray light which propagates through the optical fiber is in form of meridional rays, which crosses the fiber axis during every reflection at the core and the cladding boundary, as which can be seen clearly in the image. So the next type of optical fiber is So the next type of optical fiber. So the next type of optical fiber is graded index optical fiber. So in this type of a fiber, the core has a non-uniform reflective index that gradually decreases from the center towards the core cladding interference. So because of this, the ray propagates through it in the form of skew rays or helical rays. It is not cross the fiber. It does not cross the fiber axis at any time, like in step index optical fiber. So next, we will be talking about the advantages of fiber optic cables in communication. So the optical fiber are thin strands of glass through which a laser beam can travel for several miles, and laser amplifiers are needed only every 6 or 7 miles to strengthen the light signals. So this is a very good way of transferring of data, and a very fast way, because laser amplifiers are needed only in every 6 or 7 miles to strengthen the light signals. The scattering and the distortion of the light signals is very less. In the laser field, fiber optics is that several fibers can be wrapped inside one cable, and each cable contains many laser beams, each carrying billions of bits of information. So the next advantage is multiple signals can be sent with high quality and low loss by light propagating along the fibers, and the lasers are more nearly monochromatic, and this allows a pulse shape to maintain better over long distances. So the next advantage is the fiber optic cable has a much greater bandwidth than the metal cables. The amount of information that can be transmitted per unit time of fiber over other transmission media is its most significant advantage. The fiber optic transmission are virtually noise-free, and they can be used as the endoscopics in medicines and engineering to see inaccessible places. So the next we are going to talk about the application of optical fiber. So there are optical fiber has a very significant role in many of the industries. Like first is data transmission. The main application of the fiber optic cable is data transmission in the form of light. At first, the audio video signals are converted into electronic signals, which are further converted into light and transmitted through the optical fiber. At the receiver point, again, the light is converted into electronic signals, which are decoded into the original form of data. So the next application is telecommunication. Due to lighter weight, very high speed, and high bandwidth, high accuracy optical fiber is used in telecommunication system. So the next field of the uses of in which the optical fiber is used is military communication. Optical fiber provides high security, no electrical or magnetic interference, and a high signal quality. That is why optical fiber gives many advantages in the military communication system. The military communication system uses sonar technology, hydrophones, where optical cables are used. So next we will be talking about fiber Bragg grating, FBG. Fiber lasers are not only important components in telecommunication system, but they are also used in optical sensing applications. Sensors of this kind offer some significant advantages over the other sensors. For example, the laser yield high output power as well as significantly improved signal to noise ratio in the measurement system. So also no external sources are needed for the measurement. Next, the introduction of the fiber Bragg grating into a fiber laser system extends the functionality of the laser, such as selection of desirable laser wavelength and the tunability of the laser. The main advantage are easy operation, low operating cost, and high quality, lightweight, compact size. So thank you.